All right, and then I'm gonna hide this. All right, so on Friday, we were talking about how which model? Arithmetic or geometric sequence? Arithmetic. Our arithmetic sequences can be modeled as what type of functions? Linear. Arithmetic sequences can be modeled as linear functions. Please ignore the fact that the jackhammer is causing my room to shake, and that's going to keep randomly vibrating. I apologize for that. Huh? Whatever it is, it won't stop. It's been doing it all morning. I'm trying not to go crazy. All right, here we go. So we're talking about Alan. Alan is assigned a book to read for his biology class. Counting today, Monday, as the first day, he finds that he must read through pages 385 by day 12, and then through page 655 by day 20. Okay? So based on what we have here, what's given to us? Like if we were to mark our text and highlight what we have, what's given to us? We know our day 12, right? And we know that we have our day 20. Agreed? Anyone disagree? All right. So if I was to write those in terms of an arithmetic sequence, it would be A sub what? This is the tricky part. Would it be 12? Because your first day would be where you start, right? So this is actually going to be A sub 11. Okay, so A sub 11 would be our 385. And instead of day 20, it's actually day 19. Because we're not counting that beginning part. At least what it told me to tell you. Okay, so do I have enough to write a rule, to create a rule of what's taking place? Yeah, I have two values, right? Yes.
I think I missed something. Like, why is it day 11?
So the first day is your 0.
Yeah.
So day 1 is called 0.
Yeah.
Right? So day 1 is 0. So day 2 is actually day 1. So everything is going to be 1 less than what it actually is. Does that make sense? So this is our initial. And then it goes do. Okay? Sequence. So when your sequence, it says this is our first day. All right? All right. So there are 2 possible equations I can write. What are the 2 possible equations I can write? I have 2 given values, right? Because I have 2 given values, that means I have 2 possible equations that I can write from this. Do you remember how or why that's possible? Nope. Ringing bells? Okay. Okay. We can find, well, slope, we got to find the slope. The slope is going to be the same, but where you starting your value makes a difference. So it's going to be, first we have to find our slope. Like, how did it change? Our difference, right? Common difference is pretty easy. How do we find our common difference? 6. Perfect.
20 minus 1.
Which is still going to be, which is still 8, right? That didn't change. Okay, so we're going to find that value. We plug it in, and we get our D. Our D is going to stay the same, but our equation can be altered. Okay, the reason why our equation can be different is because remember we said that depending on what your initial value is, your A sub K, that's going to affect what your N minus K is going to be, right? So if we use A sub 11, then my K is 11, right? If we use A sub 19, then my K is going to be 19. That's why you have multiple possibilities of what you could write. Okay. Yes, y'all remember that from your 2A.1. There's different ways to model it. Hopefully, it was our last Wednesday. The video, y'all said it was so great. It was so good. What do we get for D?
Question. So is this
35? Yes.
The way you set up that equation, the whatever or what, is that just kind of a general rule? Is that always apply to this problem?
This right here?
Yeah.
This is our general rule.
Further about that. D equals what?
Oh, yeah, because you're just finding slope. Changing, yeah. Yes, change in rate. Never change. Remember I told you we'll be doing change of rate all year long. Yeah.
Rate of change.
Rate of change, change in the rate. It's all the same. That's it. All right, so here we go. On our first one, if we do a sub n, option number one is a sub n equals, if I'm using a sub 11, then it would be 385 plus, what's our change? Our constant change? 35 times n minus 11. Okay, if I didn't use that one, but I chose to use a sub 19, or a sub 19 would be, what is its value? 665 plus 35 times n minus 19. Do we see how we can have two different models?
That A11.
I didn't mean to write the n. I didn't mean to write the 19.
Oh, that's right.
Yeah, this should be n. Okay. So when I say that there's more than one possibility of writing the equation, that's because we have two values that we are using to talk about. Does that make sense?
Yeah. Yes, you do.
You see it?
Yes.
All right. Okay, so this is kind of summarizing from 2A.2 part 1, tied along with 2A.1. All right. So now, as I just go through, it's just now analyzing questions. Okay. So from here, it says, what is the common difference? Well, what does that mean in terms of Alan's assignment? What's my common difference? 35. My common difference is 35. D equals 35. What does that mean is happening then?
You read 35 pages every day.
There we go. It means Adam needs to read. Isn't it Alan? I called him Adam, didn't I? You know? Alan. My bad, bro. Alan needs to read 35 pages per day. Okay? Based on our formula, how many pages does Alan need to read today? So based on where we're at today, how many would he need to read? Huh?
35.
On Monday? Yeah, I have to have read. I'm sorry.
Monday to Monday, would that be times 7?
So that would be a gap, like Monday to Monday would be 7, right?
Yeah.
So 7 days later, by now, I'm assuming how it's read.
What?
So from a Monday to a Monday, like if this was, he started on a Monday and now he's at a new Monday, at a new week.
Like a week, yeah.
So in a week, right?
What if you do it times 6? Because they,
Or do we actually use our today?
Today's
Today's Tuesday. But today's Tuesday.
then you would have.
No, it says today, Monday. I'm Monday.
Because
I'm 35. What did you say, 35? Could you read 35 pages every day?
Yeah.
Yeah.
Maybe we're just overthinking it and it should just be 35 pages. I was like, he just needs to read 35 pages. I was ready to do some real math, y'all. I was ready to plug in and evaluate something. 35 pages. If it asks, it says explain how do you know? Because it's 1 day of reading, it's one rotation, one term. Yeah. All right, so Friday. So for Monday to Friday, are we all agreeing that's 4 days? Yes? Are we in agreement? All right. So now, well, he's on Monday, so we're now going Tuesday, Wednesday, Thursday, Friday. So by the end of Friday, he needs to have read how many books? I didn't count Monday, did I? Nope. I said Tuesday, Wednesday, Thursday, Friday, which makes it 4 pages. What did I say? Books. Same difference. Thank you. Thank you. All right. So we have four days of full reading, correct? And then 4 days and reading 35 pages a day.
Not waiting on Friday.
Yeah, I said I'm not including Monday. So I have Tuesday, Wednesday, Thursday, Friday. That's 4 days. Agreed? And so how many pages is that? 140 pages by the end of business day Friday. So, yeah, it was a little wordy. We got it done, Alan. Don't worry. Every time I hear Alan, I think of the lady, the no, it's a dance, a Halloween dance, the witches brew. Yeah, she's like, you got it, Alan? Okay, Alan. And that's what I keep hearing in my head every time I say it. All right. So that's summarizing last week. Now we're leaving linear and we're about to enter into exponential. Exponential is what she was really excited to tell y'all.